Coding theory is a branch of mathematics concerned with transmitting data across noisy channels and recovering the message. Coding theory is about making messages easy to read. The simplest method for detecting errors in binary data is the parity code, which transmits an extra parity bit after 7 bits from the source message. However, this method can only detect errors. The only way to correct them is to ask for the data to be transmitted again. A simple way to correct as well as detect errors is to repeat each bit a set number of times. The recipient sees which value 0 or 1 occurs more often and assumes that that was the intended bit. The scheme can tolerate errors rates to 1 error in every 2 bits transmitted at the expense of increasing the number amount of repetition. The disadvantage of the repetition scheme is that it multiplies the number of bits transmitted by a factor, which may prove unacceptably high. In 1948, Claude Shannon, working at Bell Laboratories in the USA, inaugurated the whole subject of coding theory by showing that it was possible to encode messages in such a way that the number of extra bits transmitted was as small as possible. Unfortunately, his proof did not give any explicit recipes for these optimal codes. It was 2 years later that Richard Hamming, also at Bell Labs, began studying explicit error correcting codes with information transmission rates more efficient than simple repetition. His first attempt produced a code in which 4 data bits were followed by 3 check bits, which allowed not only the detection but the correction of a single error. It is said that Hamming invented his code after several attempts to punch out a message on paper tape using the parity code. If it can detect the error, he complained, why can't it correct it? While Shannon and Hamming were working on information transmission in the States, John Leach invented similar codes while working on group theory at Cambridge. These research included work on the sphere packing problem and culminated in the remarkable 24-dimensional Leach lattice, the study of which was a key element in program to understand and classify finite symmetry groups. The value of error-correcting codes for information transmission, both on Earth and from space, was immediately apparent, and a wide variety of codes were constructed which achieved both economy of transmission and error correction capacity. Between 1969 and 1973, the NASA Mariner probes used a powerful Reed-Muller code capable of correcting 7 errors out of 32 bits, transmitted consisting now of 6 data bits and 26 check bits. Over 16,000 bits per second were relayed back to Earth. A less obvious application of error-correcting codes came with the development of compact discs. On CDs, the signal is encoded digitally. To guard against scratches, cracks, and similar damage, two interleaved codes which can correct up to 4,000 consecutive errors, about 2.5 mm of track are used. Audio disc players can recover from even more damage by interpolating the signal.